This is the second part of the lesson on geometric distribution. So here we will be concentrating on how to calculate probabilities for a geometric distribution. Let's have a look at a first example. Repeated independent trials are carried out in which the probability of success in each trial is 0.66. Correct to three significant figures, find the probability that the first success occurs, the first part A, the first success occurs on the third trial, part B on or before the second trial, part C after the third trial. So we can write X. We let X represent the number of trials up to and including the first success. Then we can say that X follows a geometric distribution with a parameter P 0.66. So here it is given that the probability of success in each trial is 0.66. So where P is equal to 0.66 and 1 minus P, that is Q, will be 0.34. So this is Q. Part A. We have to calculate the probability that the first success occurs on the third trial. So here we have to calculate probability X is equal to 3. So using the formula, we have the formula probability capital X is equal to R as Q power R minus 1 times P so we have to use this formula. So here we replace R by 3 and then Q is 0.34 power 3 minus 1 is 2 and then we have to multiply by P times 0.66. So the answer is 0.0763 to three significant figures. So this is part A. Now for part B, we have to find the probability that the first success occurs on or before the second trial. On or before the second trial, this means that we have to calculate the probability X is less or equal to 2. That is probability X is equal to 1 plus probability X is equal to 2. So the first success can occur on the first trial or on the second trial. So probability X is equal to 1. So we obtain success on the first trial itself. So it is P plus here success is obtained on the second trial. That is we have failure on the first trial, failure which is Q or 1 minus P, and then success on the second trial which is P. So we have 0.66 plus 0.34 times 0.66, which will give us 0.884. Three significant figures. Now let's see the last part. The probability that the first success occurs after the third trial. So here, after the third trial, that is probability x is greater than 3. So we have to do 1 minus probability x is less or equal to 3. Greater than 3 means 4, 5, 6, 7, 8 up to infinity. So we cannot calculate the probability in this way because we don't know where to stop. So what we are going to do, we know that the total probability is 1. So we take 1 minus the value of r before 4. So we have 1, 2, and 3. So we take 1 minus probability x is less or equal to 3. So here we have 1 minus the probability x is equal to 1 plus probability x is equal to 2 plus probability x is equal to 3. So we have 1 minus probability x is equal to 1, it's p. Probability x is 2, it is q times p. Probability x is equal to 3. This means we have failure on the first two trial. This is q square. And then on the third trial, we have success. Next, we replace p by 0.66 and q by 0.34. And the answer obtained is 0.0393 to 3 significant figures. Now, for larger values of r, the following results will be useful. Suppose we have to calculate the probability that x is greater than r. This means that the first success occurs after the rth trial. If we have greater than 4, this means that the first success will occur after the 4th trial. So this means that before we obtain only failures. So this means that we have failure on the first r trials and then failure on the first r trials. The probability is obtained as, so for the r trials we have failure. So it is q power r. First trial q, second trial it's q, third trial q. So this continues until the rth trial, which is q. So here we have r terms. So the probability will be q times q times q times q. This will occur r times. So it is q power r. So this is the first result. Now if we have probability Second one, if we have probability of capital X less or equal to R, this means that the success can be obtained on one of the first or trial. This will be, so if we have probability x greater than r, which is q power r, then probability x less or equal to r, it's the complement. It will be probability x less or equal to r. This will be 1 minus q power r. This can be obtained from the result above. Greater than r, it's q power r. Now the complement, it is x less or equal to r, and then we know when we add up these two we should get 1. So here it is 1 minus q power r. So this is the second important result, which is useful when we have large values of r. So now we'll take an example on how to use these results. In a particular country, 18% of adults wear contact lenses. Adults are randomly selected and interviewed one at a time. Find the probability that the first adult who wears contact lenses is one of the first 15 interviewed. And the second part, not one of the first 9 interviewed. So here we define X as the number of adults interviewed up to and including the first one who, here we are interested to know who is the first one to wear contact lenses. Then X follow a geometric distribution. So the probability of success will be 0.18 because it is given that 18% of adults wear contact lenses. So this is 0.18. So we have P 0.18 and Q 1 minus 0.18, which is 0.82. Now the first part, we have to find the probability that the first adult who wears contact lenses is one of the first 15 interviewed. So among the first 15 interviewed, we may have one among them who wear contact lenses. So it can be the first person interviewed, he can be the second one, the third one, up to the 15 persons who is going to be interviewed. So one of the first 15 interviewed, this means that he can be one among the first 15. So here we have X less or equal to 15. So if we wanted to use the previous method, just as the first example, we would have to calculate probability X is equal to 1 plus probability X is equal to 2 up to probability X is equal to 15. Here we would have to calculate 15 probabilities. The calculation would have been too cumbersome. So instead of using this method, we can use the formula. So we use 1 minus, if we have probability x less or equal to r, it is 1 minus q power r. So here we have 1 minus q, 0.82 power r being 15. This is easier, so we obtain 0.949. Second one, probability that the first adult who wears contact lenses is not one of the first 9 interviewed. So the first person who wear contact lenses will not be found among the first 9 people who are interviewed. So all 9 will not wear contact lenses. So probability x is greater than 9. So the first success, the first people who wear contact lens must be after the 9th person. So the first 9 person will not wear contact lenses. So we have failure 9 times. So it is q power 9. 0.82 power 9, which is 0.168. We have another example where we will make use of these two important results, that is probability x greater than r, which is equal to q power r, and then probability x less or equal to r, which is 1 minus q power r. A coin is biased such that the probability of obtaining heads with each toss is equal to 5/11. The coin is tossed until the first head is obtained. Find the probability that the coin is tossed at least 6 times. So here we have a biased coin. That is why the probability of obtaining head is not half. It is given as being equal to 5/11. So we have the probability probability of obtaining head, which is P, we will write P is equal to 5/11. So the probability of obtaining tail will be Q is equal to 1 minus 5/11, which is equal to 6/11. So the coin is tossed until the first head is obtained. We will continue to toss the coin till we get a head. Find the probability that the coin is tossed at least 6 times. This means that it is on the 6th or after the 6th toss that the first head will be obtained. So in the first part, we have to calculate probability at least 6 times. That is, we will need 6 tossers or more than 6 tossers. So here we have greater or equal to 6. One way to calculate this probability is by taking 1 minus probability x is equal to 0, 1, 2, 3, 4, 5. So this is one way that we can obtain the required probability. It is quite easy. It can be calculated easily. But there is an easier way. We can use this result. but here we have greater or equal to. In the result we have only greater, strictly greater. So instead of writing probability x greater or equal to 6, we can write it as probability x greater than 5. These two are the same because here we are taking, if we are taking greater or equal to 6, this means we must take values 6, 7, 8, 9. Here if we are going to use probability x greater than 5, again it will be, the values will be 6, 7, 8, 9 and so on. So these two are similar, but we will write it in this way because we can use this result. So probability x greater than 5 can be obtained directly. It is q power 5. So in this example, q is 6 over 11, then power 5. So we obtain 0.0483. As you can see, this method is easier than this method. This requires more calculation. Here the calculation is very simple. So as you could see, we can transform this inequality into this one. In part B, we have to find the probability that the coin is tossed fewer than 8 times. So we will obtain our first head in less than 8 tosses. So we have to calculate the probability that x is less than 8. So if you want to use this result, we will have to transform it into less or equal to. Here we have strictly less. So its equivalent form is probability x less or equal to 7. These two are same. Let us check. X less than 8, this means that we have values 1, 2, 3, 4, 5, 6, 7. X less or equal to 7, we have values 1, 2, 3, 4, 5, 6, 7. So these two are the same. So if we have to calculate probability x less or equal to 7, it is this result. It is 1 minus q power r. So here this probability is 1 minus q power 7. Here r is 7. So we have 1 minus 6 over 11 power 7. So we obtain 0.986. So this lesson was on how to calculate probabilities. So we have two important results, which is probability x greater than r and probability x less or equal to r, which are very, very useful when we have large values for r. So that's all for this lesson. Thank you.